right, everybody, we are so happy to have you all here today. We are going to get started. So I would like to welcome Dr. Sophia Tran.
Hi, everyone.
And for those of you joining us, we do have some interpretation opportunities today. We have someone doing some ASL interpretation for us, and we also have some Spanish translation. If you would like the Spanish translation, just go ahead and hit the interpretation button if that is what you would prefer. So Dr. Tran, welcome. I am so happy to have you here with us today.
Thank you for having me. I'm excited.
Well, I'm excited because you and I know, but our guests don't yet know that I don't only know you from interviewing you. You also happen to be my chemistry professor. Isn't that true?
It is 100% true. You are in my chemistry lab right now.
Bizarre. So
small world. It is such a small world.
Dr. Tran, you work at the Metropolitan State University of Denver, where you are a chemist. And I remember on my first class with you in person, you compared yourself to a character in a book. What character was that?
I did. I do this every single semester. I compare myself to Professor Snape from Harry Potter because he is a potions professor, and potions is basically wizard chemistry. You take all these different roots and Eye of Toad and whatever else you have to do, and you mix it together to make these new potions or chemicals, or compounds. And that's basically what real life chemists do.
Wow, that is absolutely incredible. So you said that chemistry is kind of like real life potions. Can you tell us a little bit more about that? What do you mean by that?
I mean, it's kind of like magic, right? Science is science, but how cool is science? It's basically magic, right? And Harry Potter is magic. So I feel like it just goes hand in hand,
That absolutely makes sense. Yeah. And in the books, Harry initially thinks that Professor Snape is a bad guy, and like we spoilers, but we find out by the end that he actually has some pretty good intentions. What would you say to a student who maybe had the wrong impression of you?
Yeah, I like to always tell my students that that's how the the comparison goes even deeper, because sometimes people think I'm a tough professor because chemistry can sometimes be a tough subject. But I think just like Snape, I am here to just help people, and I always tell my students that people that are in the teaching field like me and your teachers at school and any other teachers that you have in the future are really there because they want to share knowledge with you. And sometimes that can be a little hard because learning things can be a little tough. Sometimes you're getting new material and trying to commit it to memory. But we're there to help you along the way, just like Snape was to help Harry.
I absolutely love that comparison. And I will say, as your student, I don't think you're mean at all. I think that you're pretty nice and very helpful.
Thank you so much.
So we've said that chemistry isn't magic, but it kind of seems like magic or almost like a superpower sometimes. So I'm going to go ahead and poll our audience and ask them how they would use their chemistry superpower. Would they use it to protect the environment, or maybe create a new medicine? Or are they wicked and would they make evil potions for their evil plans? Or perhaps work with inventors to create new inventions? Oh my goodness, and I see that the poll is taken off already. We have a whole lot of people who say that they would protect the environment, though evil potions is growing. How about you, Dr. Tran? Which of those would you choose?
I think I would probably protect the environment. They're all really, really great things, great options, but I do love the environment. So I think I would protect the environment for sure. How about you, Tessa?
I'm definitely going to make evil potions for my evil plans, Dr. Tran. Why would you
Of
suspect
course.
otherwise?
Why would I ever guess anything else? Yeah.
Though the environment is important and medicine is also important.
Absolutely. These are all great. There's no bad option.
Very, very, very true.
Yeah.
Can chemistry actually help do any of these things, though? These all seem like just kind of a superhero kind of thing.
Oh, 100%. We could do all of these things with chemistry, you know? We could come up with new chemistry or new chemicals to help protect the environment. And in that case, we would just be, you know, for anyone that knows about climate change, you know, there's a lot of CO2, carbon dioxide in the atmosphere right now, and that's not great for the environment. And so actually some of my friends in graduate school were doing research on how to kind of like suck all of that CO2 out of the air, you know, because it's not great to have as much as we do in the atmosphere right now. So, you know, that's an example of how chemistry could protect the environment. You know, I think biologists and chemists work towards creating these new vaccines that we have for COVID-19. And so that's been like a huge accomplishment by scientists, chemists included. Evil potions, yes, you know, bad chemicals. So, and then lots of different inventions can come from chemistry, you know, like the different chemicals and materials that you would need to make something like actually physically that you could hold. That is part of inventing new things.
Wow, that's amazing. I didn't know that chemistry was able to do all of those things. I'm very surprised and very, very, very grateful. So we have some folks in the chat asking us about some clerical issues. So this program will last until 6:45. And for those of you who are typing in the chat, I know that you're not able to talk to each other, but we do see everything that you type. So we will be able to see what you are explaining to us in the chat, and we are happy to answer all of your questions. So we've talked a little bit about what chemists can do. So let's do a little bit of like a hot seat. Can chemists make things change color?
Yes, always. When we let me unofficially poll the audience right now. When we think of a chemist, what do we imagine? You know, we probably imagine someone that sorry, I was reading the chat. I got distracted. It's like I'm in class, Tessa. When we think of a chemist, we think of someone in a lab coat, maybe with some crazy hair, you know, with beakers of bubbling solutions, and usually they're different colors, you know, and we imagine that chemist just pouring solutions from one beaker to another. Tessa was doing this in lab a couple weeks ago, right? And all those solutions change color. That's something we definitely think of when we think of chemists.
And Kenzie's just wondering, there's no way chemistry could make a rainbow, though, could it?
I mean, if you look at the experiment that I have for everyone, it's kind of like a rainbow, right? You take that red cabbage indicator that I have you make, and you add different acids and bases to them or to it, and it changes color. And then you can kind of make this gradient or a rainbow of different colors, and it's super cool.
That is incredible, and it sounds like a lot of fun to do at home.
Yeah, totally.
I've read in books about some acids that are like so powerful that they can even burn through glass. Have you ever had to deal with chemicals like that?
Yes. In school, in graduate school, I worked with a lot of kind of crazy and dangerous chemicals, ones that I had to wear a lot of protective equipment for to make sure that I didn't get hurt. But acids, strong bases, chemicals that burst into flames if they come in contact with oxygen, which is all around us. So crazy stuff.
That sounds really epic. I'm just gonna put it out there.
It's pretty cool. I have some wild stories from grad school, like some accidents that maybe may or may not have happened, you know? Yeah.
And I know when you're a chemist, you often perform experiments. Has there ever been an experiment that you were just really surprised by the results?
Oh, that's a really good question. I think, you know, I keep talking about graduate school. So after I went to college, I enrolled in a PhD program. And that's how I became a doctor. That's why I have the doctor in front of my name. And I would say that during graduate school, you're doing a lot of research. So you're trying to discover new things, kind of like those inventions that were mentioned in the poll. And I was able to discover a new compound that no one else had made before. So that was pretty exciting. I did that twice, actually, one time in undergrad and one time in graduate school. So that was pretty exciting, you know? And I think those kinds of experiments are always the ones that both myself and my friends always really think are special, because we know that we're the first people to ever make these compounds.
Did you get to name it Dr. Tran Compound 1 and 2?
Unfortunately not, because, you know, chemistry already has a system in place as to how to name chemicals. So, but I did print out a picture of the chemical, gave it to my mom, and she posted it on her fridge. So, and I think it's still there many years later now.
So we started to talk a little bit about kind of your background. When did you know that you wanted to be a chemist?
Yeah, you know, to be completely frank, I did not know that I wanted to be a chemist specifically until I was in college. But since I was a really, really tiny child, I loved math. And then I probably didn't have a science class until I was in middle school. And I really, really loved science then too. So I've always loved math and science. And so I went into college knowing that I wanted to do something with science. I wanted to go into medical research at the time. And then, um, you know, I took biology, and I personally wasn't a huge fan. I think biology is super, super cool, but it just didn't speak to me the way that chemistry did, because I was in my chemistry class and I loved it so much. I loved sitting in lecture. I loved doing the labs and everything. At that point, I just decided, you know what, I'm gonna major in chemistry. I'm gonna get my college degree in chemistry. And then I got involved in some research. So I joined a lab, and that's where I discovered that new molecule that I was talking about. Um, and in that process, all of my mentors and the people that helped train me to be a scientist, they all saw this potential in me, and they just kept saying, you got to go to grad school. You got to go to grad school. And I said, okay, you know. And something that's really cool that a lot of people don't realize is that when you go to graduate school, so you go to school after college, to get your PhD in a STEM field, you usually get paid to go to school. They don't pay you a lot, but they pay you to go to school and learn about science and do cool experiments all day. And it's super awesome. And so I did that. And during grad school, I decided that I realized that I love teaching. I love talking about science. I love teaching people about science. And now I'm here teaching at Metro, teaching Tessa, teaching all of you about pH. Yeah.
And for those of you wondering about Dr. Tran's pH experiment, you can find it in the Clubhouse or on our DMNS YouTube page. So make sure that you go ahead and check it out, because it's really sweet. You get to chop up cabbage. It's real fun.
Arguably, I would say that that's probably the most boring part of the experiment. But you get to make things change color, right? And who doesn't want to do that?
Yeah, it's really great. I did it myself, and it was a lot of fun. I promise. It's really, really good.
Yeah.
So you talked a little bit about some of your mentors. Who are some of the people who inspired you on your journey, both inside of school and also outside of school?
Yeah, you know, I think my first and foremost, always got to give props to my parents. You know, I am the daughter of two Chinese immigrants, so they came to America from Asia, and they worked really, really hard to be able to provide for me and be able to give me the opportunities that I've had. And so I think it's been a real inspiration for me outside of science and school, um, to see how hard they've worked to try to give me as many opportunities as possible. You know, so they pushed me and inspired me to do as best as I could. So that was really important for me. As far as school and science goes, um, yeah, I had a elementary school teacher that let me skip gym class to do math problems. and that was solid. So I skipped going to the pool to swim because Dr. Tran doesn't know how to swim, just FYI. And I would do math problems sitting next to the pool instead. And that continued to grow my love for math. And then, yeah, in college, just getting those opportunities to work in a lab and figure out what I loved to do was amazing and awesome. And everyone that I worked with was super supportive, you know.
That sounds amazing. So we know that you're not a swimmer, right? Just to clarify, not a swimmer?
Not a swimmer,
Not a
never.
swimmer.
Never.
But there must be some things that you do outside of chemistry. And before you answer, how about we turn it to the folks in the chat? What hobbies do you have outside of school? What do you like to do other than just learn?
I'm so excited to see everyone's responses. Oh, swimming.
Swimming is the first one.
Of course it was the first one. Of course.
But there's more. We have some folks who like to mountain bike. We have a lot of folks who love to read and love to bake. Some artists in the chat. Ooh, some folks who do Irish dancing and karate. Oh. I did those when I was a kid.
Oh, yeah?
Mm-hmm.
Go fossil hunting. Where are you going fossil hunting? And can I come with you?
Oh my goodness. Some folks, Brooklyn here seems like she has so many things that she does as a hobby. She must be really busy. Laura plays with her puppy. Do you have any pets, Dr. Tran?
I do not. I am allergic, unfortunately.
Alas.
Yeah.
Alas.
I know.
Some gymnastics. Incredible. Okay, so you don't play with your puppy and you don't go swimming. What do
Correct.
you do? Though Kenzie's giving you advice. She says, just get a hairless cat, Dr. Tran. Come on, hairless cat.
You know, I don't want to say anything controversial, but hairless cats scare me just a little bit, Kenzie. Just a tiny bit. Okay. Same. Why did you suggest it? Oh, I love that. So like a lot of the people that are responding in the chat, I also love to bake. I make sourdough bread, bake all the cakes, all the cookies, everything. And love to cook. The more difficult the dish is, the more I am drawn to it. So also, like unofficial poll, I'm just going to take over for Tessa here. If you want to tell me what your favorite thing to cook or bake is in the chat, I would love to hear what everyone's favorite thing is. And if you don't like to cook or bake, tell me what you like to eat, because I would love to hear that too. And what else do I like to do? I like to sew. So during the pandemic, I started sewing a lot of face masks, right? So everyone should be wearing their face masks when they're out. And I sewed this little sushi pencil bag for myself, which is super cute. So yeah, I love to sew things. I like to work out, lift weights, go to the gym, run, love hanging out with my friends, which hasn't been easy, you know, for the past year. So that's been a little hard. A lot of people are saying they love cake. We need to be more specific. What kind of cake, you know? Firecracker meatballs. That sounds really good. Now I'm hungry, y'all. Baked potato soup. That sounds good. Banana bread, banana cream pie. I love banana cream pie. That is my favorite type of pie. And for everyone, Tessa, I'm sorry that I'm just completely taking over for you.
Please feel free.
Sunday is March 14th. Happy Pi Day. Yes, Laura. So pi is a super important number in math. It's 3.14. And March 14th is considered Pi Day. So if you can get your hands on a pie on Sunday in the midst of this impending snowstorm, I would say do it and celebrate Pi Day. It's my favorite holiday.
So with our remaining 5 minutes, I want to open it up to questions and answers. So you can ask Dr. Tran anything. It can be about chemistry, or it can be about her life. You might ask, what's your favorite element on the periodic table? Or we know now how much you loved baked goods, but what would you put on a pizza? You can ask Dr. Tran anything, and she will be able to answer you live. I already have a couple of questions pulled from the chat. One Brooklyn is repeating right now. Is cooking related, or is cooking related to chemistry?
Oh my goodness, 100%. Yes, cooking and baking are 100% related to chemistry. So, for instance, when you put baking soda and vinegar together, you get a really kind of ferocious reaction where we get bubbling and gas forming, right? And so that's an acid and a base that we mix together, okay? And we get CO2, carbon dioxide, that gets made out of that reaction. And so when we make a cake and we see that the cake rises a little bit, sometimes, or not sometimes, all the time, when we put a cake into the oven, it starts out this high and then it gets a little higher, right? It rises a little bit. That's because we have some sort of chemical reaction that's happening in there that creates gas, and that gas expands, and that's what makes the cake rise, And that's just I'm just scratching the surface, right? There's so many other things that are chemistry related in our cooking and our baking.
Wow. We have the chat is just blowing up.
Blowing up.
People have a lot of things to ask. This is from a lot earlier in the chat. When we were talking about acids melting things and burning through things, someone wondered, is lava an acid?
I actually don't know the answer to that question, but I know that lava is really hot, and that's probably why it melts things. More so, like, it is so hot, it doesn't even matter if it's an acid, because the heat's gonna eat right through you first,
So maybe your cabbage and lava, maybe the interaction going on there would be more about adding water to something really, really hot, and not really about an indicator. Someone keeps asking, did you know that E equals MC squared? But I'm going to add on to that. Did you know that E equals MC squared? And do you ever use that equation as a chemist?
So I do know that E equals MC squared, and I have never used that as a chemist. I think it's a physics thing, isn't it?
Yeah, I think it's a physics thing. And then kind of a more serious one. Someone was wondering, have you ever been underestimated because you're a woman in STEM?
Yes, 100%. It's really, really unfortunate. I think, in today's climate, I think things are a lot better, and there are a lot of female scientists in chemistry and biology and all these different fields. But yeah, it happens. And I think during grad school, there were a lot of people who questioned whether or not I should be getting my PhD, and maybe I wasn't smart enough to be getting my PhD. And that was really, really hard. And I think in order to overcome that, I had to look inside myself and find my own confidence of, wait, not only am I smart, I was smart enough to get here, but I work really, really hard. And this is something I absolutely love, right? And so the combination of my hard work, my passion for chemistry, and then just my grit, like, I'm going to stick to this because I know why I'm here and this is what I want to accomplish. And I think there was a little bit of Dr. Tran just thinking to myself, who cares what they think? It matters what I think about myself and what I know I can achieve, And so it's really just always about looking back at yourself and understanding, hey, this is why I want to do this. This is what I love. And I'm just going to focus on that passion and that excitement about what I'm doing.
That's an incredible, incredible answer. In our last 30 seconds, someone's wondering, have you ever made elephant's toothpaste?
I have. It's my favorite. Yes. It's the best. Have you made elephant's toothpaste? Have you, Tessa?
I have, actually.
Yes.
Recently, I've made elephant's toothpaste.
Oh, fantastic. Yeah, it's the best. It's my favorite.
I know I've done it, but I would love for you to just tell us, what does elephant's toothpaste look like? What reaction is happening there?
All right, everyone. So get a pen and paper, get ready. Okay. You need some yeast. You need some hydrogen peroxide. For the parents out there, you need that hair developer. You need the stuff from the salon. Okay. And then you need soap, and you need food coloring, and you need a long, narrow tube, like a Coke bottle or something. Okay. And you're gonna mix the yeast with the water and some soap, and then you pour the hydrogen peroxide in there. Kablowie. Okay. The hydrogen peroxide breaks down, oxygen gas everywhere, bubble, 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 because there's soap.
Well,
I only had
like
30
we got-
seconds, so I had to go fast, you know?
We got a bonus experiment out of the deal. Thank you so much, Dr. Tran. It was excellent having you. We'll see you at the end of the program. You were the best. Oh, amazing. Thanks so
You're
much.
the best. Thank you so much.
Right now, let's welcome Julie Montoya. So, welcome, Julie.
Hi.
Julie has a job that is pretty out of this world, if I do say so myself, and you might be able to tell from her background. Julie is the Veers lead analyst at Raytheon Technology. Just said a lot of words, not a lot of context. Julie, what is Veers?
So Veers is really just an incredibly fancy camera that we launch up into space so that we can take pictures of the Earth. So we at Raytheon build the camera, and my job is to make sure it works perfectly before it goes on up there.
Why would you want pictures from space?
Oh, that's a great question. So a lot of people take pictures from space for gathering intelligence about things. And what I mean by that is learning more. So Veers takes pictures to learn about the environment. It's specifically a weather satellite for NASA. So NASA and NOAA want to know more about forest fires, the atmosphere, the ocean color, the vegetation. And so all of those are pictures that Veers can take.
Oh, that is so cool. And it sounds like you're kind of making Veers for NASA, and someone is asking in the chat, are you an astronaut? Do you know any astronauts?
Well, I personally would not go to space. It seems kind of uncomfortable up there, but I would love to send anyone that wants to go. I did meet a couple of astronauts. I got to sit in on a panel for Buzz Aldrin and Michael Collins at the 50th anniversary of the Apollo launch. It was so cool. They're really funny guys.
Just remind us, who are Buzz Aldrin and Michael Collins, and why do I have a shocked face right now?
Buzz Aldrin is the second man to ever set foot on the moon, and Michael Collins was in the orbiter, orbiting around the moon while that historic spacewalk was occurring, moonwalk was occurring.
That's just the coolest thing in the entire world. And just to clear it up for Laura in the chat, what does NASA mean? What does that stand for again?
That is the National Aeronautic and Space Administration. So all things space come through NASA.
Gotcha.
So our future Mars program, down to our low Earth orbiters that are taking pictures of the Earth.
Ah, so cool. So you work on a giant space robot. What do you do if, while it's in outer space, something breaks down? Do you just call up Buzz and say, hey, Buzz, will you hop up to outer space and fix my robot for me?
Well, Buzz is retired, so I don't think he'd go up there. So it's actually really fun when something, which sounds counterintuitive, that it's fun when something goes wrong, but it's super fun. Now you can't see it, you can't touch it, you gotta just get as much data as you can. How hot is it? What voltage is it at? Were there any storms going on in the atmosphere at that time? And you use all that data and you fuse it together and you try and figure out what happened, and then you can try and solve the problem. And it is absolutely my favorite part of the job. And I should add, it's not just me. Everything we do, once it's up in orbit, takes a team of people. So it's a lot of teamwork, a lot of coordination to get that data, understand it, make a plan, try and send up new commands to the spacecraft while you're in touch with it, while it's orbiting over the poles. It's super fun.
Oh, that sounds amazing. It also, dare I say, sounds a little bit stressful. Just a little bit stressful.
That's what I always say. Space is high stakes engineering. That's why I picked it.
Nice. Well, let's turn our audience into some high stakes engineers real quick, and let's ask them a question. Let's ask, if you could collect something about the Earth from space, what would you pick? Would you find out information about the weather, or maybe locate the best forests on Earth, or track a wildfire to keep people and animals safe, or maybe do all of those things? What do you think? Oh, people in the chat are really going for that all of the above. They're really passionate about all of those things. We have some folks really looking for the best forests on Earth. Why do you think, why would it be important to collect information about the weather from space?
So all of these things that are in this poll are things that Veers can do. So Information about weather can help people that are planning, say, a rocket launch, understand the weather patterns that are going to go on in the air as the rocket's going up so that we can make sure that it gets to space safely. Looking for the best forests on Earth is another way of saying you're tracking vegetation. We want to know, where are things growing in this world and where are things struggling to grow, because that's indicative of a drought, of a serious drought. Dr. Tran was talking all about climate change. This is one of the best ways for us to keep an eye on it. And then that last one, track a wildfire. Boy, I'm from California and it's been getting worse and worse every year. And I actually have a friend that uses Veers. She lives up in Santa Barbara, and Veers is her first indicator of when she needs to evacuate. So it's doing some really, really important work.
Wow. What are some other ways that Veers can be used to help people?
To help people?
Mm-hmm.
Well, Veers is a ocean color monitor. So it is telling you the health of your oceans, which if you as a person wants to go for a swim, wants to know where a healthy ocean is, Veers is also a nighttime camera. So that's maybe its coolest feature, is it takes these pictures at night and it can find all the artificial light that's going on in the world. And so we use it in disaster recovery. So when there was a hurricane in Puerto Rico a couple years ago, we were able to fly over Puerto Rico and take a picture right after the hurricane. And that helped them tell where the lights were on and where they still needed to be restored. We did the same thing last month in Texas. So we can really use these nighttime pictures to help people out that are facing huge disasters.
And you talk about taking pictures at night. Laura in the chat is wondering, or I'm so sorry, Laura, I'll get to your question in a second. Georgina is wondering if you collect infrared and ultraviolet images as well.
Yes, Veers has cameras that extend in the visible spectrum and then all the way out into the thermal. So we are getting some infrared images of, and I call that temperature pictures. But yes, we are very interested in the temperature of things, because actually that's the best way of finding a fire. It's harder to see a fire, but it's very easy to find where something's a lot hotter than the things around it.
Huh. Very, very, very interesting. So we've talked a lot about Veers, but we haven't talked a lot about like you and Veers and your relationship with Veers. You say you're a lead analyst. What exactly does that mean?
It's the best job on the program. So Veers is a camera. And so in order to test it, we take 1 million pictures. So from the time we start building it to the time we send it on orbit, and even while it's orbiting, it's just constantly taking pictures. So my job is to look at those pictures and then use math, which is the best, to tell you if everything looks right. So we can convert the color red, for example, to a color or to a number. And then I can tell you whether, numerically speaking, that picture of that thing is as red as you think it is, or that picture of that thing is the temperature that Veers is telling you it is, right? And so we have to do all of these tests, and I'm the one that does that math, and it's so much fun.
Oh, so you're not an astronaut, but kind of like when in the movies they go, Houston, you're kind of more like Houston in that sense.
I'm Houston, exactly.
Whoa, that's incredible. And it sounds, again, like a lot of responsibility. I loved what you said earlier. What was it? Space science is the highest stakes science or something?
It's high stakes engineering, for sure.
Whew. Pretty incredible. So it sounds like maybe you like math just a little bit.
Math is my favorite.
What subjects in school did you love that help you with your profession now?
Well, so as we were discussing, math is my favorite, and I think that everybody listening needs to pay the most attention in their statistics class. It's often overlooked. It's not as fun and exciting as calculus, but statistics is what everybody uses everywhere. Everything you use, your phone, your television these days, Veers, everything is big data. And so you have to understand how to talk about that data, how to manipulate that data, how to draw conclusions from it. And that's what statistics is. That's your average, your standard deviation, your mean, median, mode. All of that is the most important thing to pay attention to while you're growing up.
Wow. Okay. I am also in a statistics class right now. And because of you, I'm going to pay more attention. I promise. I'm going to pay a lot more attention. Have there presently and also historically been a lot of women in your field, or were they not as common?
No, I think I am hopefully the last generation that will grow up this way, where I'm the only girl on the math team, the only girl in the calculus class. I am lucky to have a bunch of female coworkers, but certainly we are outnumbered by our male counterparts. So all of you that are listening need to grow up and be engineers so that you can come work with me.
How about historically? Have there been any trailblazing women that kind of gave you inspiration to pursue your career?
Yeah, I mean, there are a lot of really brave female astronauts that I feel like are worth mentioning. So Sally Ride, Ellen Ochoa, Mae Jemison, all of them were brave enough to stand up and go into space as the first women, and I am eternally grateful to them because they give me something to do down here on the ground.
And you've met some of your historical heroes or women who have done things in the field before you. Isn't that true?
I did. A woman named Poppy Northcutt was in mission control in the Apollo age. And that was a huge deal because this is the 1960s now. So not a lot of women were doing that. And so she sat in the mission control room while Apollo was up there going to the moon, and provided guidance as an engineer. And gosh, would I love to do that. Gosh, would I love to do that.
It does sound super incredible. I bet you'll get there soon. That's you're gonna be right there. So it sounds like you kind of already met one of your STEM heroes. Let's ask in the chat, if you could meet any historical or present day woman in STEM, who would it be? Who would you choose to meet if you were gonna sit down and have a hot cocoa with them? I might choose to meet Florence Nightingale. We were talking about Florence Nightingale not a long time ago, but my mom is a nurse and she really, really, really admired Florence Nightingale. Amelia says she would meet Marie Curie. Lori says she would meet Katherine Johnson.
That's so nice.
Brooklyn says that her grandma was actually a pioneering woman as one of the first women to fly a plane.
Katherine Johnson, I see that answer. She was actually, talk about a dream job. Back in the day, her job was to just go to work and invent new kinds of math and just do the hardest, most complicated math. Sit down with your pencil and your paper all day long and just do math. And I mean, dream job.
It seems like you really, 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 really like math. And clarification, it was her friend's grandma, not her grandma. Though we have some lovers of Amelia Earhart, and I noticed earlier a lot of these young women in the chat want to become astronauts or pilots, just like Amelia Earhart. Abby's loving Jane Goodall, who I bet Veers would have helped her with her studies of chimps by helping study the forests shrinking and growing in that area.
Yep, we could have helped her out.
Pretty incredible stuff. So how did you get into this profession? It's clear that you love math. I'm pretty sure at this point that you love math. But were there any moments from your childhood that now you look back on and you're just like, yep, that makes sense. Of course I'm here. That was me.
Well, my dad was a math teacher. So from the get-go, I'm actually the third oldest, and he tried to sell math to both of my older brothers and they did not take it. And so when he got around to me, I was his last hope. So I really glommed onto it. I was on the math team as soon as they would let me. And my favorite thing in the world was to come home and show my math team ribbons to my dad and see the look on his face. Space specifically, it was actually not until college. We were watching a video on the Challenger explosion. It was just an extremely tragic event, but they went into detail on all the engineering and all the decisions that were made. And in that case, skipped over or made incorrectly that led to the explosion. And that's when it hit me that like everything you do when you're a space engineer is so critical. I mean, in that case, people's literal lives were in your hands. But for me, I mean, Veers is an incredibly, think hundreds of millions of dollars camera. And so everything I do, I have to be triple sure is correct. And also once you send it up into space, you can't go back and get it. And so it just all it appealed to me that like, it was so high stakes, so important. And I wanted a job like that, where every day you went into work and you were challenged in a very high stakes way.
That's amazing. I really admire your ambition. It's really, really, really cool to see somebody like that. But you can't always be working. You can't always be just tabulating. Outside of work, what do you like to do?
You know what? One of my favorite things to do to relax is knitting. And I know Dr. Tran mentioned she's a sewer, and I think that hobbies like that kind of appeal to women in science because you're following a pattern, or you're inventing your own pattern. And so it really, it's the same part of my brain, but it's a completely different use of it. And so that's one of my favorite things to do.
Oh, that's incredible. So we have 5 minutes left for questions. So I would love to hear from everyone in the chat what kinds of questions you have. It can be something about space or Veers or something random. You could ask about what the temperatures and conditions are like in outer space, or maybe whether she has any pets. And I have some that I've already pulled. How did you launch Veers into space? And also, what does Veers stand for?
Oh, good one. Veers is the Visible Imaging Infrared Radiometric Sensor Suite. So that's a mouthful, but visible, as we were talking about, and infrared, that's the important part there, that it's taking colored pictures and temperature pictures. We put it aboard a rocket, an Atlas rocket, and we launched it out of Vandenberg at 3 o'clock in the morning. Turns out that's the exact time that you need to launch something so that it can easily get to low Earth orbit. So we all trooped out into the middle of a field 3 times, because the first 2 nights the launch got aborted because of weather. And then the 3rd night it went up there. It was super exciting. It was super exciting to be there. Like watching your kid go off to college, I'm sure.
But with more rumbling. If you could invent a new invention for outer space, what would you invent to put into outer space?
Gosh, I think that I would like to invent a rocket ship that could carry humans into space that would be like roomy and comfortable, because all the ones that I see so far kind of look like you'd be a sardine in a can.
That makes a lot of sense. Someone's wondering, Kenzie is wondering, what's a fear that you have trouble getting over sometimes?
You know what, I think that I'm a pretty normal person, and that sometimes I feel like I'm not good enough or not smart enough for my job, especially when I first started. I remember calling my math teacher dad and crying and telling him that I don't know why they hired me. And it's real, it's there. And I think a lot of people have it. And you just have to buckle down and prove yourself wrong. I guess you just sit down with your pen and your paper and your statistics and slowly work on the problem till you get the answer.
Awesome. And then a lot of people are wondering, do you have a pet?
A pet? I do. I have 2 puppies. One of them is named Butter, and her brother is named Chewbacca, like from Star Wars. And he looks like a little Ewok.
That is adorable, and Ayla agrees. She says, "Aw." Somebody was wondering about that earlier too. Is Veers only pointed at Earth, or can you take pictures of other planets?
So Veers, as designed, points at the Earth 99% of the time. There is a brief calibration we do right after we launch where the whole spaceship kind of does a belly flop. But that is non-nominal. Gets really hot when you start looking up out at the stars and the sun. So we do not like to do that if we can avoid it. And most of the time, no, we are looking down at the Earth.
That is super, super, super cool. And in our last 30 seconds, we talked about a hero that you met in real life, but if you could meet any historical woman in STEM, who would you meet?
Oh gosh, I think that I would like to meet Margaret Hamilton. Margaret Hamilton was, during the Apollo program, she wrote all of the code that got so she's the one in the famous picture, you see the stacks of code, they're as tall as she is. I am not a computer scientist, but in another life, that's what I would like to do. And if I were gonna do it, I would like to write the code that sends a man to the moon. I think that would have been fantastic.
That is incredibly cool. So let's welcome back Dr. Tran, just to say a big, 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 big thank you from the Denver Museum of Nature and Science. We really appreciate having both of you here. Thanks a ton for answering everyone's questions. And thank you so much to our ASL translator and also to our Spanish translator for helping us provide accessibility for this program. We had a great time with you tonight, and we hope to see you again soon. All right, thanks everybody. Bye-bye.